All right, let's take a look at the section 11.1 homework. In your book, this would be number 15. Calculate the amount of simple interest earned. Where P is 1,000, R is 6%, which is 0.06 in decimal form, and T is 4 years. So here we have 1,000 times 0.06 times 4, which has the value $240. Now, the next problem is actually 502 XP, right? On your homework, it's just number 3, right? And this one having been number 1, or actually number 2. Number 1 was a video. Okay, let's clear this out. For number 3, which in the book is actually 502 XP, if Rita receives $40.84 in interest for a deposit earning 4% simple interest for 30 days, what is the amount of her deposit? Here, we need to know what 30 days is, right? That's a percentage of a year. Generally, a year is 365 days, but sometimes your book uses 360. So we'll try 365 first, right? We'll need the decimal form, but we're still looking for P. Our equation is that I equals PRT, I being 40.84, P being the thing we're looking for, 0.04 being R, and then we'll look first at 365 days. Otherwise, we'll go check out what the book says, right? So if we multiply both sides by 365 and divide both sides by the 0.04 and 30, then we will have P potentially. Let me go grab my calculator. So 365 times 4084, and then divide by 0.04 itself times 30. I get the wrong answer. Okay, so that means that your book, which is strange, I agree, they're going to use oh, whoops, I was still on the eraser. They're going to use 360 for the number of days. Okay, let's see, double check this one, see if this gives us the right answer. Okay, that gives us the right answer. So your book uses the number of days in a year to be 360. And that's then how we got this answer correct. So that's probably what's holding some of us up in getting this correct answer. I know for me, every time I have to understand that this book presents the year in terms of 360 days. Okay, so that then is number 3 in the homework and number 502 in your book. Now from there, we have a video and then number 5. Number 5 in your homework, if you look in the corner, it tells you 11.01. I guess there's not a 0 there, but it tells you 11.1.019. That means it's number 19 in the book. And it has an answer, right? Because it's odd. Okay, so 19 reads, find the future value using the future value formula So any of these versions of future value formula and a calculator. So they tell us here that we have a deposit of $250 at a rate of 3 3/4%. That's 3.75%, which in decimal form is 0.0375. Simple interest, which is the formula we've written down above, for 2 years. So T equals 2 years. That's nice because T is in years for us. So we just have to fill in one of these formulas and solve for A, right? I'm going to pick the P times 1 plus RT version because we have 250 times 1 plus our rate, which the rate is multiplied by 2. So in the calculator, I would type 2 times 0.0375, enter, plus 1, enter, times 250. And I have a resulting dollar amount value of 268.75, which checks out. So that answer does match. The trick here was in the rate, I think. Okay, number 6 is number 32 in the book. So let's clear this out. Number 32. Find the total amount that must be repaid on the following note described. We borrowed $8,543 at 14.5% simple interest. So we'll just put a note that it's simple interest. What amount must be repaid? So what's the future value? 3 years and 125 days later. So 3 years plus 125 days, when we have 360 days per year in your book for these equations, right? This gives us a T in years of 125 divided by 360 plus 3. Actually, it looks better as a improper fraction. So I'm going to say 360 times 3 plus 125. That's going to give me 1205 days out of the 360 that form 1 year. So that's 3 years and 125 days. And now, let me go to the top, I guess, because I've got all this below. So A equals P times 1 plus RT, which gives me 8,543 times 1 plus 0.145 times 1205 divided by 360. Now for the calculator, I would type in 1205 divided by 360, enter, times 0.145, enter, plus 1, enter, multiplied by 8543, hit enter. This gives me the value in dollars of $12,689 and cut myself off 32 cents, right? So let me rewrite that. $12,689 and 32 cents. So definitely, I think the trick here is in the 360 days per year. That is different in the other books that I teach out of. So it's an example of you need to know what the authors of your book requires of you. Okay, then there's a video, another video, right? And now we're going to start looking at compounding situations, right? So we're leaving simple interest behind. And now we're going to look at examples using compound interest. In compound interest, we have the formula of P times 1 plus R over, I'm not sure, I think your book uses an N. Let's see, I do have the book right beside me. I might change these notations. So let me look in your book real quick. Yeah, they use the N. Okay, so here in number 9, which is actually number 21 in your book, right? So again, there's an odd number. So you have an example in your book that gives you an answer, right? So that's always nice. Here they give us that we've borrowed $673 at a rate of 5.5%, in decimal form 0.055. Compounded quarterly. Quarterly means, sorry, your book uses an N. So N equals 4. N equals 4 because we're compounding quarterly. That's 4 times per year, quarterly. And for a quantity of 3 years, right? T is in terms of years. So for our compound interest formula, then we have, they're asking us for the future value, right? So A equals 673 times 1 plus the ratio 0.055 divided by 4 raised to the exponent of 12, because N times T is 4 times 3, which is 12. So in the calculator, I would say 0.055 divided by 4, enter, plus 1, enter, raised to the power 12, enter, multiplied by 673. That gives me a value of, in dollars, $792 and 84 cents, which does match. Now, of course, calculators are capable of doing orders of operation on their own for the most part, but I do like to walk through my own step by step. Number 10 is number 23 in the book. Number 23 in the book asks us again for future value using our compound interest formula. They tell us this time that P is $44.67 at a rate of 3.5%, which is 0.035. Compounded daily, our days are 360 long, right? So compounded daily and for a quantity of 3 years. Now we know from last time we need 3 times 360, right? So 3 times 360 is 1080. And now we can fill out our formula here, right? 44.67 times the quantity 1 plus the ratio 0.035 divided by 360 raised to the 1080. Okay, so 0.035 divided by 360, enter, plus 1, enter, raised to the power 1080, enter, multiply by 44.67, enter. This gives me a value of $49.62. A lot of work for $5, right? Not a lot. That's what real savings accounts look like, though. So again, just note to self, it's this 360 days per year that makes most people wrong in these chapters. Okay, so number 11 is number 24 in your book. So we'll go look at number 24. '24 still wants us to find the future value, but what we're doing is we're practicing different compounding periods, right? This one I should read before I write, because this one wants us to use compounding continuously. So if we're compounding continuously right now, and that second, and this second, and the one that just passed, and this one now, all the time, constantly, continuously, then our future value is P times E to the RT, right? So for us in number 24, we're given a P value, not P value like stats, but P equals 119,400 at a rate of 5.5%. So 0.055 as a decimal, compounding continuously. So this formula for T equals 20 years. So we just fill out our formula. A equals P times ERT, which is 119,400 times, well, I don't necessarily need a parenthesis. I just got used to the other formula. So times, put a little X there, E, which is the Euler's number, right, raised to the caret. So raised to the power 0.055 times 20 in the exponent there. So in the calculator, I'm going to put 0.055 times 20. Oh, that gets me a decent exponent, right? So 119,400 e to the 1.1. So I have a e function on my calculator, right? I hit second, base e raised to the 1.1, and then hit enter, and then multiply by 119,400, right? Our p. And what we get after 20 years is 358,000. That's a 5. $697.42. So compounding continuously right now and now and now and now and now for 20 years will, let's see, more than double our money, right? That's pretty decent. I wouldn't mind that bank account. Okay, so the next one asks us for the future value, again, compounded continuously. So this is the next one, which is 12 on your homework, is number 39 in your book. So let's clear this out. Right, number 39 in your book. Gives us a question that reads, for compounding continuously, they want to know the future value, right? So they're asking us to fill in this equation. What is the future value after 14 years? If you deposited $1,000 for your child's education and the interest is guaranteed at 1.6%, which is 0.016, compounded continuously. So if we were to fill out our equation, we would type in 1,000 times E. Let's do RT over here, right? So R being 0.16 times 14 years gives us an exponent of 0.224, right? So this is 0.224. When I stick this in the calculator, right, I type in e raised to the power of 0.224, hit enter, then multiply by 1,000. I get the value in dollars, 12.51 and 7 cents. In the next problem, which is 13 for you and 29 in your book, they ask you to solve one question in several ways. So let's see, I forgot what I already said, number 29. And number 29 in your book, you are given a P, an investment value of 14,000. You're given an interest rate value of 0.025, right? Because it was a 2.5% interest rate. And we're given a year total of 20 years. And they're asking us to compound in several ways. So A is annually. So compounded using 1 plus R over N and T, where N is 1 for annually, right? B, semi-annually. Same equation, where N equals 2, right? C is quarterly. So that is the same equation where N equals 4. D is monthly. So use the same equation, but change N to 12. E is daily, which here at least they remind us that N is 360. Every minute, which is not continuously, apparently. Every minute is where N equals 525,600. And then for for G and H, you'll switch equations, right? So for G, for example, they want continuously. So A equals P ERT for continuously. And H is simple. So you'll just use your A equals P times 1 plus RT. So for each and every single one of these problems, you use the P of 14,000, the R of 0.025, and the T of 20, but you have to switch up one, which equation you're using. At first, you just switch in every instance, but then for G and H, you have new equations for future value, right? So you're using these three equations, different values of N, but for each one, P, R, and T stay the same. Okay, so then we've got inflation, and then we start to look for present value, right? So when you're asking yourself, what could they ask us to solve for, right? Generally, they ask us to solve for the future value. So A, these are all future values on the screen here. But then they can also ask us for the present value, right? So present value would be solved for P. So we go back actually to number 25. But first, let's take a look at number 14, which is number 45 in your book. So find the cost of a home in 30 years, assuming an inflation rate of 1%, compounded continuously if the present value of the house is $245,000. Okay, so let's clear this out. Now for 14, right, which is number 45 in the book, we've got a present value of 245,000. We're given 30 years. We're given a 1% rate. These rates are awful, which is 0.01. We're also told this is compounded continuously. So let's see. 245,000 times E to the power 3, right? So we multiply R times T, we have 0.01 times 30, which is just 0.3. Okay, good thing I double checked. See 0.3. And then we'll enter this into the calculator, 245,000 times e to the power 0.3 gives me the value in dollars, 330,715 and 41 cents. So this is the value of a house in 30 years with a 1% inflation rate, right? So I guess inflation being 1% is okay. A savings account being 1% is trash, right? So this inflation means that in 30 years, a house you can buy today for $245,000 will cost you almost $100,000 more. Let's see. Find the cost of the monthly rent. This is number 46 in the next one. Let's see, another inflation one, right? So let's see if we can fit it up here. So number 46, which is just 15 in your homework, right? Find the cost of the monthly rent for 2-bedroom apartment in 30 years, assuming an inflation rate of 5%, if the current rent is $635. So again, we have a 30-year question, and this time the rate is 5%, which considering inflation, like that's a lot, right? So A equals P times E RT. Let's see, RT is 30 times 0.05 or 1.5. So in the calculator, we can type 635, right, times E to the power 1.5, right? So 635 times my function E to the power 1.5, which is, $2,845.87. So rent is going up in 30 years, right? Okay, so I'm going to stop the video right here, right? We still have a few questions, but they kind of switch gears, like I said, and we start solving for P in some of them and whatnot. So I'm going to stop the video here and make a second video for the rest of the problems. Numbers, let's see, where did we get through? We got through number 15. So this is the end at number 15 in the actual homework. So about halfway.